This is a YouTube preview of a course called ClojureScript for React Developers. This is part 1 in a series of 3 preview videos. We will be building a to-do app using Reagent, a popular ClojureScript wrapper around React. The to-do app will be built to the specifications of the TodoMVC project, which is used by many developers to compare front-end web technologies. The to-do app will be built from scratch. The user of the app will be able to see a list of all of the to-do items and have the ability to add, delete, and edit them. Also, the user will be able to filter on to-do items that have been done or are active. In addition, features such as local storage and routing will be covered. Finally, the app will be deployed. All the steps in the development of a front-end web app using ClojureScript are covered. After seeing how to make an app using ClojureScript, you will appreciate the numerous and significant advantages over JavaScript, especially with respect to the use of immutable data structures, which are preferential when using React, and the more concise and readable code, which results in fewer bugs and less maintenance. This video is a preview of Section 5 of the full course, ClojureScript for React Developers, which is due to be released in early 2021. Earlier sections of the course will cover the basics of Clojure and ClojureScript, so it is assumed that the viewer has a basic grasp of Clojure syntax. In addition, since this course is for React developers, knowledge of JavaScript is also assumed. Earlier sections of the course also cover Reagent, the popular ClojureScript interface to React. Reagent uses Hiccup to render HTML rather than JSX, which is generally used by React developers using JavaScript. However, Hiccup syntax is so simple that viewers without experience of it will most likely have little difficulty understanding it. If you want to code along with the videos, you will need to have Java installed, since Clojure is compiled to Java bytecode, which is the instruction set for the Java virtual machine. Clojure supports Java long-term support releases from Java 8 onwards. You can use any Java installation, whether it's a commercial release from Oracle or an open source version based on OpenJDK. If you do not currently have Java installed, we recommend you go to adoptopenjdk.net and download version OpenJDK 11 and the hotspot JVM. You will also need to have Node.js installed, since we'll be using the Node Package Manager npm and its package runner npx. You can find more details in the description of this YouTube video. TodoMVC app demo. In this video, we will first introduce you to the TodoMVC project. TodoMVC is an open source project that implements a to-do web application in several frameworks and languages so that developers can compare and evaluate them. You can find out about the TodoMVC project at this URL. We will show a full demo of the finished to-do app we will be building in this section of the course. And finally, we will provide you with the URL of the to-do app we have deployed so that you can try it out before you get started building it. You can see our finished and deployed version of the to-do app, which was built using ClojureScript and Reagent, in the browser. All implementations of the TodoMVC project must adhere to the app specification, which outlines the code style and functionality the to-do app should have. Also, it provides a CSS file that has all the styling needed and an HTML template which gives the basic structure of the to-do app. For our implementation of the TodoMVC app, we will adhere to the app specification in all but a few minor details, since we will not be publishing our solution to the TodoMVC project site. That being said, we will provide the full functionality required by the specification. Let's demo the functionality of the to-do app first. We can add a to-do by typing in the input field at the top of the list, and then hitting the Enter key. We can mark a to-do item complete by clicking on the circular checkbox input on the left side. At the bottom of the list, we have a label showing that 3 items are left. We can show all the to-do items as we are now, or we can click on Active and only show the items that are not completed. Note that the browser URL has updated to show the active route. We can show just the completed to-do items. Note that the browser URL has updated to show the done route. We can delete the completed to-do items using the Clear Completed control on the bottom right. Let's click on All to show all the to-do items again. Note that the browser URL has updated to show the All route. We can delete a to-do item by hovering the cursor over it. A red deletion icon appears to the right. Click on it to delete the item. We can mark all to-do items as complete by clicking on the downward pointing arrowhead to the left of the input field. Click on it again to make all to-do items active. We can double-click on a to-do item to edit it. And finally, the to-do items are saved in local storage and therefore will persist when the user reloads the page. That's the end of the To-Do app demo. You can see this live version of the To-Do app at the following URL. Next, we will build this To-Do app from scratch. Start project with Create Reagent App. The objectives of this video are: show you how to bootstrap a new ClojureScript project using the npm package runner npx with the package Create Reagent App. Coming from React, you will be familiar with the very popular Create React App bootstrapper, which was the inspiration for the Create Reagent App package. Since we are creating our To-Do app along the specifications of the TodoMVC project, we will install their prescribed CSS styles. During this course, we will be using the Atom code editor. Feel free to use whichever code editor you like. We will show you where to find the main source code file in the generated project. Finally, we will show you how to build and run the app in the browser. We will be using Chrome during this course. We will start our project in Terminal using the npm package Create Reagent App and give it the project name To-Do. The project has been created successfully. Change directory into the project folder. Install the project dependencies. We will be implementing a TodoMVC app, and the CSS styling for it is available as an npm package. Add it as a development dependency to our project. The npm package is called TodoMVC app CSS. Next, copy the CSS file from this installed npm package into our project's public CSS file. Here's the origin path of the CSS file we are copying. That's node_modules/todomvc-app-css/index.css. The destination path is That's public/css/style.css. Open your preferred code editor. We will be using Atom. On the src/main class path, within the todo/app folder, open the core.cljs file. We can see the basic template code generated by create reagent app. We will be working only in this file during this section of the course, so we can close the project view panel on the left. Go back to Terminal and build and run the app using the start script command. The first time this command is run will take about a minute. Shadow CLJS will download the dependencies it needs. Subsequent builds are faster. Shadow CLJS sets up an HTTP server for your development build at localhost port 3000, or another port if 3000 is already in use. Shadow CLJS will first configure your build, then compile it, and when it is done with that, it will display build completed. We will speed forward in this video so you don't have to wait. Now the build is ready, open your browser at localhost 3000. Reload the browser page if necessary. If everything is working correctly, you will see the heading Create Reagent App on your page. Create basic app structure. We have a single objective for this video. We will implement the basic TodoMVC project template using Reagent's hiccup syntax. We can get started building the To-Do app. We will start creating the basic structure of the TodoMVC app with some CSS styling. Since we are implementing the TodoMVC project, the basic structure and styling are prescribed by the TodoMVC project template. All we will do at this point is recreate the project template with hiccup forms that Reagent uses. Just follow along with this part. Normally, we would be writing code in several files and require them in this core namespace. However, for demo purposes, we will be writing all of our code in this single core.cljs file. For clarity, demarcate a section for our view components with a comment. Now, demarcate the render section. Rename the app component To-Do app. Change the h1 element into a div. Within this div, add a section element. Give it the class To-Do app. This To-Do app class and all the other CSS classes we will use from now on in our To-Do app come from the npm package TodoMVC app CSS we copied to our public CSS file. Next up, as a child of the section element, add a div with the text task entry. Then add a sibling div, which wraps a div with the text task list. And a div with the text footer controls. As a sibling of the section element, add a footer element with a class called info. Within the footer, add a paragraph element with the text footer info. Now we have set up the basic structure of our To-Do app. You can see the results in the browser. Add view components. Our objectives for this video are: create a task entry view component which will consist of the header of the app, which shows the text to-dos in large font, and the text input field for entering the titles of new to-dos. The to-do input field will be its own view component. The task list view component will show the list of to-do items. And finally, we will create a footer controls view component, which will show how many to-do items are left to be done, a way to filter the to-do items, and a control for clearing completed ones. Now we will start adding view components that will split up the functionality and visual elements of our app. These are our basic building blocks. Let's call a component we will name task entry, where we created its div placeholder. We will now define the task entry component. It will consist of a header element with a class by the same name. It will contain an h1 element with the text to-dos. Next, we will call a yet-to-be-defined component called TodoInput. Now we will define the TodoInput component. It will consist of an input element and have the following attributes. Next, we will go to the placeholder for task list. Here, we will call the yet-to-be-defined task list component. Next, we will define the task list component. It will consist of a section element with a class of main. Within it, we will add a placeholder div with the text to-do list. Now let's go to the placeholder div for footer controls. We will call a yet-to-be-defined component called footer controls. Now let's define this component. It will consist of a footer element with a class by the same name. For the time being, we will add a placeholder div with the text footer controls. Our to-do app is beginning to take shape. Add app state atom. Our objectives are: decide on the data structure we will use to store our to-do items. We will use Clojure's sorted map to sort the to-do items by ID. And we will use Reagent's reactive version of Clojure's atom as the mutable reference to our immutable to-dos map. We are going to add state to our application. First, let's demarcate some space in our file for the app state using a comment. Our app contains to-do items, which are a key part of the state of our application. Now, we need to decide the shape of the data structure to store them in. Each to-do item should be a map, with a title which describes the to-do task a Boolean flag showing whether the to-do task has been done yet, and a numerical ID, which will help with access and sorting. Since we will have multiple to-do items, we will wrap them all in a map, which will have the IDs of the to-do items as keys and the to-do items themselves as values. Even though we are duplicating the ID in this data structure, it will make it much easier and faster to access individual to-do items, and also make sorting them more efficient. Let's define an initial sample of to-dos to get started. We will add 3 sample to-do items. This is our first one, with the ID of 1 as the key and the value being a to-do item map. We will put the other 2 out of order, so that we can show them sorted afterwards. Now, we will put them into a sorted map, which will sort the to-dos by their numerical IDs. An atom is a mutable wrapper around an immutable data structure. We can update our application state using an atom, switching out the immutable representation of our state within it. Our sorted to-do map will be stored in a reagent atom. Reagent atoms react to changes. Reagent keeps track of the components the atom is dereferenced in, and then re-renders those components and any of their child components when the atom is changed. We will refer to a reactive reagent atom as a ratom. To use reagents atoms, we will require the reagent.core library in our namespace. Now we can define the ratom for our to-do state. To ensure our ratom does not get another value when our code is hot reloaded, use def_once to bind the variable. Give the to-do's ratom the initial to-do's sorted map as its initial value. We now have a way to update our to-do's data structure, which is the core state for our application. Render list of to-dos. Our objectives are: we will show you how to render a list of to-do items using Clojure's list comprehension macro. React requires developers to provide a unique key to each item in a rendered list. We will use metadata to provide the key prop. The user of our application will want to see the list of to-dos in the app. We will implement that in our task list component. First, create a local binding to a variable named items. Dereference the to-dos atom and pull out only the values from the map, putting them in a sequence. Items is therefore a sequence of to-do items, that is, a sequence of maps containing the ID, title, and done fields. Let's reformat the rest of the component so that the parentheses are correctly applied. Now we will create an unordered list where we currently have the placeholder div. We will give it the CSS class of ToDoList. Use a list comprehension to step through the to-do items. We will bind each item in the sequence to the variable name to-do. So for each to-do in items, create a list item showing the to-do title. Notice that we are getting a warning in our console. Every element in a sequence should have a unique key. We will fix that by adding some key metadata to our list item. The metadata will be a map with a single key by the keyword key, an associated value being the unique ID of our to-do. Save the file and notice that the warning is no longer showing in our console after the hot reload. We have successfully created a visual list of to-dos for the user to see. Add to-do item view component. We have one objective in this video. We will separate the to-do item within the list comprehension into its own component. We will now make the list item showing the to-do title into a separate component called to-do item. The reason for doing this is to add more functionality to each to-do item, separating out the additional complexity from the task list component. We will pass the to-do as an argument to the to-do item component. Now, define the to-do item component. Destructure the title from the passed-in to-do parameter, which is a map. The component will render a list item element. As its child, add a div with the CSS class of view. In turn, add a label element as a child, showing the title text. Good! We now have a separate to-do item component, to which we can add more functionality. Add to-do item. Our objectives are: create an add to-do function, which will update our to-do state with a new to-do item. We will see that in order to add a to-do item, we will need to provide a new unique ID, so we will create a counter as a piece of state using a ratum. We will make use of the swap bang function, which has the side effect of swapping out the old to-dos map with the updated map in the ratum. Finally, we will save the new to-do item when the user blurs the text input field, that is, when it loses focus. The text field loses focus, for example, when the user clicks elsewhere in the app. A basic feature of any to-do app is enabling the user to add new to-do items to the list of to-dos. We will now implement this feature. We need a way to add a new to-do item with a unique ID. Since the ID is numerical, and more specifically, an integer, we could add some state to our app to keep track of the last ID used, in the form of a counter, for example. Define a variable named counter, which isn't rebound on hot reloads. Bind it to a ratum, which wraps an integer with the initial value of 3, since we already have 3 sample to-dos. Carve out an area in our code file for utility functions and bindings. Define a function that will add a to-do to the to-do state. It will take some text as its parameter. Add some local bindings. First, we will need the unique ID of the added to-do. We will swap out the counter ratum with an integer value increased by 1. Now, we can bind the new to-do to a map with the ID we've just calculated, and the title key to the text passed into the function, and a done boolean of false, since new to-dos are not completed yet. Finally, the function will swap the to-dos map with a new copy, which associates the incremented ID with the new to-do. Our add-to-do utility function is complete. Next, we'll add UI to the to-do input component so that the user can input a new to-do item. Add a local binding for the input text, bound to a ratum initialized with an empty string. Add a binding for a function to update the text, which resets the input text to the passed-in argument to the function. Define a binding to a function named save, which calls the add-to-do utility function, passing in the dereferenced input text value as its argument. Since we have added bindings to local state in our reagent component, we will need to return a closure to render the hiccup forms. This is a so-called form2 reagent component. Our input element will be controlled with a value prop, which will be the dereferenced input text. We will save the to-do when the user removes focus from the input element, firing the so-called onBlur event. On each keystroke, that is, whenever the onChange event is fired, we will do the following. What we have done here is call the local update text function, passing in the event's target value, which is the text in the input element. The text changes on each keystroke. Note that using this methodology, we only save the to-do and therefore update the to-do's state when the user has finished typing and removes focus from the input element. This is more efficient than updating the to-do's state on each keystroke. Let's test it out in the browser. We will add a to-do item. Now, when I blur the input field by clicking elsewhere, this to-do item should be added to the list. Clicking away now. Good! We have successfully added the feature that enables the user to add a to-do item. Watch the state. The objectives of this video are to use the addWatch function so that we can print out when the to-do's atom changes. The addWatch function takes 4 arguments, which we will show. We will make use of the CLJS pprint library to print out changes to the to-do's atom in the Chrome Developer Console. Now let's add a feature that will help us while developing the app. It would be great to be able to see the state of the app, nicely printed to console, whenever it changes. One of the advantages of using atoms for state management is that it makes it very simple to implement this developer-facing feature. Let's demarcate an area in our code file for this functionality. Clojure exposes a useful function called addWatch for us to use in order to watch our state atoms for updates. The addWatch function takes 3 arguments. First, the atom to be watched. Second, a key specified by the developer. And third, a watch function, which is fired whenever the atom changes. We will watch the to-do's atom. We will simply call the second argument, which is a keyword, to-do's. The final argument, the watch function, takes 4 parameters. The 4 parameters are the key we specified, the atom we are watching, the old state value before the change, and the new state value after the change. In our example, we are only interested in the key and the new state value, so we have prefixed the other two with an underscore to indicate that we are ignoring them. Our addWatch function will print our key when it updates. And it will also print out the atom's new state value. Let's try it out in the browser. I will add a to-do item. Now I will blur the text field by clicking elsewhere. We can see the to-do's atom current value printed out to the console. To improve the formatting of the printed atom value in the console, we can use a CLJS library called pprint. We will require it in our namespace. We will use its pprint function instead of println when printing the new state value to console. Let's go back to our browser to see what updates now look like when printed to the console. First, let's add another to-do item. The printed atom value in our console is now much easier to read. Good! You will find the addWatch functionality extremely helpful while editing and debugging your code. Add keyboard events. Our objectives are: we will clear the input field after adding a new to-do so that the user can more easily add another to-do. In addition to saving a to-do when the user blurs the text input field, we will enable the Enter Keyboard event to also save a to-do item. Also, if the user hits the Escape key while entering a to-do item in the text input field, we will clear the input. After the user adds a to-do item, it would be helpful if the input text were cleared automatically. We will reset the input text to an empty string in order to facilitate this user-facing feature. Let's create a local binding to a function named stop, which resets the input text to an empty string. Now we have done that, we should update the save function to call the stop function after addToDo has been called. In order to invoke more than one function call, we will wrap them in do. Call the addToDo function, passing in the dereferenced input text. And then call stop, which will empty out the input text. As our next user-friendly feature, we'll add a to-do when the user hits the Enter key on their keyboard. In addition, when the user hits the Escape key, we'll exit out of the input field and empty it out. First, add a local binding to a function named keyPressed, which should test the input argument representing the key pressed using the case macro. If the key pressed is Enter, then call Save. If the key pressed is Escape, then on Internet Explorer or Edge browsers, test for the string ESC and then call Stop. Or on other browsers, test for the string Escape and call Stop. Otherwise, do nothing. Second, we can attach an event handler to the onKeyDown event. As its handler, pass a function that calls the locally bound keyPressed function with the event's key property. Let's test our new features in the browser. We will add a new to-do item. Now, when I hit the Enter key, this to-do should be added to my list, and this text field should clear. Hitting Enter now. Good, that works. Next, let's see if we can escape while entering a to-do item. Hitting the Escape key now. Good, we have successfully implemented these user-friendly features. Thank you for watching. Hit the subscribe button now to get more free ClojureScript videos.